अनकंट्रोलेबल, सेमी कंट्रोल्ड और कंट्रोल्ड। अनकंट्रोल्ड का मतलब ये होता है, ठीक है, ऑफ से ऑन जाने में आपकी मर्जी है।
अगर टी की पावर नेगेटिव है और
यूनिट ऑफ एनी कैलकुलेशन रेट आ रहा है करंट
आई नॉट R1 प्लस GS1 ड्रॉप
या इक्वल तो कितने लोग बोलेंगे तो यहाँ हम फार्मूला लगाएंगे, फार्मूला लगा देंगे। बेटा क्या लगाओगे?
ऑफ से ऑन जाने में आपकी मर्जी है।
अगर टी की पावर नेगेटिव है और
यूनिट ऑफ एनी कैलकुलेशन रेट आ रहा है करंट
आई नॉट R1 प्लस GS1 ड्रॉप या
इक्वल तो कितने लोग बोलेंगे तो यहाँ हम फार्मूला लगाएंगे, फार्मूला लगा देंगे। बेटा क्या लगाओगे?
हेलो एवरीवन, एक बार जरा मुझे बताइएगा क्या वॉइस प्रॉपरली आ रही है? एक बार मुझे बता दीजिएगा क्या वॉइस प्रॉपरली आ रही है बेटा? सॉरी फॉर द डिले बेटा जी, एक बार मुझे प्लीज़ ज़रा इन्फॉर्म करें क्या वॉइस प्रॉपरली आ रही है बेटा? अगर वॉइस का कहीं कोई भी इशू हो तो प्लीज़ मुझे ज़रा जल्दी से बता दें, क्या वॉइस प्रॉपरली आ रही है बेटा जी? वॉइस प्रॉपरली आ रही है बेटा? एक बार मुझे इन्फॉर्म कर दो जरा, वॉइस क्लियर है सर? ओके, गुड इवनिंग एवरीवन। देयर वाज अ लिटिल बिट ग्लिच जिसकी वजह से थोड़ा सा डिले हुआ, ठीक है। सो अभी हम लोग जो है वो पैरेलल ऑपरेशन ऑफ अनइक्वल वोल्टेज रेशियो और साथ ही साथ पैरेलल ऑपरेशन ऑफ इक्वल वोल्टेज रेशियो को कंप्लीट करेंगे। This batch is an impulse batch and I tried to complete parallel operation of equal voltage ratio of transformer, remaining part of the parallel operation of equal voltage ratio of transformer as well as unequal voltage ratio of transformers operating in parallel. Before going to start, please observe my name is Varun and my subjects are electrical machine control system and digital electronics. I have more than 10 years of teaching experience for electrical machines in both GATE and ESE on both online and offline platform. You can use my code VST101 in order to get 10% discount as well as to get access of free special class. Sir, from where we will get the free special class access? Now please see, for that you need to download Unacademy learning app on your mobile phone from Google Play Store. Then open it, fill the required detail and choose GATE and ESE section. and then just use VST101 code wherever it will be asked. Is it okay? Sir, how to get the free special class? If you observe, the live chat box of this video shows a link. That link is my special numerical batch. Okay, you can just click after completing this procedure. You can click on that link and start learning. Is it okay? You are not going to get the access of my special class videos, but you are going to get access of all Unacademy educators special class access. There is a lot of difference between the Plus, YouTube and recorded version. Always try to follow all educators on Plus. Now please see, two type of paid courses is offered by Unacademy, that is Plus and Iconic. Iconic will have all the features of Plus along with the extra feature of personal coach. If you talk about fee structure, then fee structure is just 27,225, but you will get this fee structure only after applying my code VST101. So sir, why we are going to use your code? Because if you are using your code, then it means you are my responsibility and you are going to study under my supervision. Okay, you may go by the 24-month plan. The fee structure is 39,600 only, and EMI option is also available. If you are willing to go by the Iconic subscription, where you will get an extra mentor along with me, so for that fee structure is 66,600 for 2 years and 45,225 for 1 year. Okay, you can use my code. This code will give you 10% discount. So this code gives you 10% discount in paid subscription. It gives access to all free special classes, as well as if you are using this code, it means you are getting a personal attention. Is it okay? Very good. Now please observe, there is one more chance to get the entire course for free. If you think that the fee structure is not affordable for you, then Unacademy gives you a chance to show your knowledge and get the subscription for free. You can register yourself for Unacademy Combat. For that, you can use my code VST101. Is it okay? On every Sunday, the test is scheduled at 11 AM. So next is going to be on 25th. If you are going to be the best performer like the previous ones, you may get the subscription for free. Is it okay? So if you are from first 3, you are going to get the subscription for free. Now why sir we have to take the subscription? Because if you observe here, Kasser Hafiz sir is going to start from 22nd Power Electronics. Power Electronics is very important subject for electrical machine, and he is one of the best faculty for electrical core subjects. Is it okay? Presently I am taking electrical machine on Plus. This class is started from 9th of April, but you can easily get the revision of the previous classes and then you can continue along with me. BV Reddy sir started network this month. Okay, so if you are willing to join Unacademy, then this is the right time, because you are getting all the important subjects. Is it okay? Now please see, if you are going with a video solution, if you are going with a combat, you are also getting a video solution that improves your performance as well as that boosts your knowledge. Is it okay? Please tell me, please let me know whether all the informations are clear to you or not. If you have any doubt related to the subscription, you can contact me. Feel free to contact at any time. Okay. Now come to the today's lecture. We are going to discuss about the parallel operation of equal voltage ratio transformers. Is it okay? Now please see, I am taking a quick recall of the last class, and then we will proceed. You need to share this session because we are on YouTube, and the purpose of YouTube is to care students. So there will be a responsibility to the students also to share this session and show the love of electrical machine, and also that you want the entire lectures to be continued in future also. Okay, so you need to share this. Sir, what is the Agni batch? Agni batch is for the Ethan selection, HPCL selection. So if you are ready to get the information of Agni batch is going to be started very soon as HPCL. All information already available on website and it is in a detailed version. So the batch is also going to have a detailed information right from 0 to top required for the selection of HPCL. Okay. Now please see here. In the last class of parallel operation of two transformers having equal voltage ratio. So I am writing here parallel operation of two transformers operating in parallel. Parallel operation of two transformers having equal voltage ratio. Having equal voltage ratio. Parallel operation of two transformers having equal voltage ratio. So this topic already I have covered in the last lecture. I am just going to take a quick recall. So the transformers are represented by their internal impedances and the induced EMF will be represented in terms of a voltage source. Okay. In the last class we have discussed up to this part. Let us suppose we have the two transformer A and B having a impedances RA XA and RB XB as the internal impedances of the transformer and the induced EMF on the transformer on secondary side as EA and EB. So this will be your RB and JXB. The two transformers are operating in parallel and the transformers are of equal voltage ratio. When I am saying equal voltage ratio, it means EA is equals to EB. Is it okay? Yes, sir. So while operating in parallel, the voltage appeared across the load say V and load current say IL. So IL is the current delivered by transformer A plus current delivered by transformer B, where IA is the current delivered by transformer A and IB is the current delivered by transformer B. Okay, you need to share this session as much as possible. Sir, can I purchase only machine lecture of you on app? Basically beta, it is not a subject wise. The subscription is as per the month wise, 6 month, 3 month, 6 month or 12 month. So if you are going to purchase a subscription for a month, maybe you will complete the machine, but that is not the live one. You will get a recorded one. For a live lecture, you have to purchase at least for 3 months. Okay. Now please observe here. IA, IB, terminal voltage V, IL is equals to IA plus of IB. Now please observe. We have calculated KVA delivered by each of the transformer operating in parallel when the total load KVA is SL. Already I have derived this formula that KVA delivered by transformer A is SL into ZB upon ZA plus ZB and SB is equals to SL conjugate into ZA upon ZA plus ZB, where we have to keep in mind that ZA and ZB are in actual ohms or in per unit on common base. Please share this session as much as possible. So till up to this part already we have completed. Okay. Today I am interested to know about the maximum KVA that two transformer can deliver while operating in parallel. Okay. And for that I am going to take one numerical. For that I am going to take one numerical. Are you ready for the numerical? Please write in the comment section. Are you ready for the numerical? Put your calculators out. So this one numerical is going to give you the complete information related to the parallel operation of two transformers having equal voltage ratio. Are you ready, beta? Okay. So see, please observe, I am taking one numerical in order to understand parallel operation of two transformers having equal voltage ratio. Please observe here. This is a comprehensive course, so you have to make your notes by your own. Okay, it is just like an offline class, only the module is online. Now see, two single phase transformers are operating in two single phase transformers A and B are operating in parallel. Transformer A 2500 volts by 250 volts, single phase 50 hertz, per unit impedance 0.01 plus J let it be in this way, 500 kVA Z per unit 0.01 plus J 0.06, okay, and transformer B 2500 by 250 volts 250 kVA Z per unit is 0.01 0.012 plus J 0. Make it equal, 0.02 plus J 0.012. So I am taking the calculation in this way. Okay. Please see, these are the descriptions of the transformer A and B. Okay. Please, you need to share this session as much as possible. Sir, IPL कौन जीतेगा? IPL तो कोई ना कोई जीत जाएगा, लेकिन HPCL कौन जीतेगा? That is the question. HAL कौन जीतेगा? IPL तो कोई ना कोई जीत ही जाएगा. ठीक है भाई, चलिए. You may take a short-term goal, like you will be happy by winning some team IPL. If you have used some amount, then maybe you are going to get some fair amount also, but that is one time, and you may get a selection on some good PSU. It's upon your choice. Tick. Transformer A, transformer B, and now find the load shared by each transformer when total load is 600 kVA at 0.8 total load is 600 kVA of 0.8 power factor lagging. Also calculate the maximum kVA, the approximate maximum kVA that can be delivered by this parallel combination. बहुत ही जबरदस्त। क्या लिखा है सर आपने? आ जाइए। क्या लिखा है सर आपने? देखिए, प्लीज ऑब्जर्व। Two single phase transformer A and B are operating in parallel. Specification of transformer A and B is mentioned onto the nameplate of the transformer. So that I have mentioned here as 2500 by 250 volt 500 kVA per unit impedance is 0.01 plus J 0.06. Another transformer B 2500 by 250 volt 250 kVA Z per unit 0.02 plus J 0.12. Find the load shared by each of the transformer when the total load is 600 kVA of 0.8 power factor lagging. Also calculate approximate maximum kVA that can be delivered by this parallel combination. Most of the student thinks that, sir, one transformer is of 500 kVA, another transformer is of 250 kVA. So if we are going to operate them in parallel, then they can share a load of 750 kVA. But that is not true. Why, sir? Now we are going to examine that one. You have to share this session as much as possible, bhai. Now please see. You have to take the screenshot of this question so that question is with you, and then I am going to proceed it. Completed? Just make a thumb in the comment section. हाँ जी. See beta, this year is really very difficult. Even 2020 is also very difficult for many people. Some of very close relation we have suffered a lot due to COVID. But abhi bhi we can't change the things which are not in our hand. Like if I am a doctor, then I try to make this year to be a good, or I try to make some peoples to be healthy or happy, but it is not in my hand. कुछ लोग ऐसे भी थे जो कि चले गए, जिनका ध्यान नहीं दे पाया, कोई भी नहीं दे पाया. So that is not in our hand. But the things which are in our hand, at least we have to try to make that one perfect. Is it okay? और ये बहुत जरूरी है. बहुत, जब भी मनुष्य जो है ना सबसे कठिन समय में रहा है, तभी उसकी जो सबसे ज्यादा क्षमता है वो बाहर आई है. तो ठीक है, अभी ये जो प्राकृतिक आपदा है, इससे बचने का एक ही तरीका है कि जो हमारे साथ हो सकता है, जो हम बेस्ट अपना परफॉर्म कर सकते हैं, जो हमारे पास संसाधन है, उनके साथ करना चाहिए. एंड वी मस्ट हैव टू केयर ऑफ सेल्फ एज वेल एज अदर. सो वी नीड नॉट टू गो आउटसाइड. Try to be in your home, try to study, try to utilize your time, try to make your exercises, all which are important for your health as well as for the others. Okay, that is very important. लॉकडाउन इज, देखो कोई पूछ रहा है सर लॉकडाउन लगाना चाहिए. लॉकडाउन ये मैं डिसाइड करने के लिए बहुत छोटा आदमी हूं यार. इट इज डिसाइडेड बाय अ ग्रेट पॉलिटिशियंस एंड ग्रेट मेडिकल हेल्थ एडवाइजर्स, है ना. तो ये यार वो लोग ज्यादा बेहतर जानते हैं. मैं ये अच्छा जानता हूं, मैं तुमको ये सिखा सकता हूं. सो इस पे मैं जरूर तुमसे बात करूंगा, ठीक है ना. नाउ सी सर, load kVA is given to you. So please observe. Load kVA is given to you. Load kVA is given to you 600 kVA, and Power factor is 0.8 lag, so you can write it as cos inverse 0.8. One thing you have to remember always, that for a lagging kVA angle is positive and for leading kVA angle is negative. Why? Because complex kVA is always defined as VI conjugate. Okay, so I am representing here plus is for the lagging in case of kVA. kVA angle is opposite to the current angle. If current angle is negative, then kVA angle will become positive because of the VI conjugate, and generally we take V as a reference. Okay, now please observe here. So you can say, sir, 600 kVA at an angle of cos inverse 0.8. When the two transformers are operating in parallel, transformer A and transformer B, per unit impedances are given to you. But the per unit impedances given are based on the rated values selected as a base value, because the nameplate values are always taken as a base value to represent per unit values onto the nameplate. So onto the transformer nameplate, the per unit values mentioned is based on the rated values selected as a base value. Is it okay? So this per unit value is on the rated base of 500 kVA and on the rated voltage base of 2500 on HV side and 250 on LV side. If you observe transformer B, then per unit impedances of transformer B is onto the base of 250 kVA and 2500 volt on HV side, 250 volt on LV side. Okay. So the two transformers having different base kVA, and therefore the per unit impedances are on the different bases. Okay, sir. Okay, sir. But when we have to use the formula for kVA shared by two transformers operating in parallel, either we have to go by the actual ohms or we have to go by the per unit impedances on common base. That is very important thing. Now please observe here. This load is given to you. This is the punch point of this question. Please observe. The current is IL, that is equals to IA plus of IB phasor sum. This is your IA and this is your IB. Now please see, kVA shared by transformer A conjugate will become, sir, SL conjugate into ZB upon ZA plus ZB. Now it is very important to select common base for both, because if you are going to divide it by Z base, equivalent upon Z base, equivalent upon Z base and equivalent upon Z base, then Z base are going to be cancelled out only if the base impedances are on the common, per unit impedances are on the common base. Is it okay? Yes, sir. So you can say, sir, in this formula, ZA, ZB and ZA, ZB are either in actual ohms or in per unit on common base. So I am writing here where ZA and ZB are in per unit on common base or in actual ohms. So first of all, we have to select a common base. It is best to take the rating of one transformer to be selected as a base value. It is in your hand. You can select any one of the two transformer ratings as a base rating. Okay, it is in your hand. So you can just suggest me which transformer rating we have to take it as a base. Whatever you want, you can take that one. I am taking 500 kVA as a base. So now please see, if we are going to select one transformer rated values as a base value, then at least for that transformer we need not to find the new per unit value. Is it okay? Yes, sir. So Z per unit of transformer A is, I am going to select, let the base impedance is, base kVA base is 500 kVA, and I am going to select rated voltage as base voltage. As both the transformers have same rated voltage, so voltage is not going to affect. Yes, sir. Now please observe, ZA per unit of transformer A is 0.01 plus J 0.06, ZB per unit transformer new value will become ZB per unit of transformer old value into KVA base, or you can write it MVA, it is better to write MVA base new upon MVA base old into KV base old by KV base new square. Now old value is the rated values of transformer B and new value is the values which we have selected as a base value for finding the common base for both. Is it okay? Yes sir. Now please observe here, Z per unit is 0. I am finding it out here. Please observe 0.02 plus J 0.12. Okay. So 0.02 plus J 0.12. This is the previous per unit values based on the transformer B values, rated values selected as a base value, and now I am going to find the new per unit values on a new base. Is it okay? So both per unit impedances are going to be on the common base. New MVA base is, since that is a ratio of MVA by MVA, so it doesn't matter whether you have to put it in KVA or MVA. So 500 upon 250 into KV, voltage rating is not going to be changed, so it will remain same. So it will become twice. So this will become 0.04 plus J 0.24. Is it okay? Now we have per unit impedance of transformer B and per unit impedance of transformer A on common base. Is it okay? Are you able to understand up to this part? Yes sir. Current divider rule. We have calculated the KVA delivered by each of the transformer from the current divider rule only. Already I have derived that in the last lecture. Now please see. So sir, KVA delivered by transformer A conjugate will become 600 KVA, that is load KVA, 600 KVA, load KVA at an angle of minus of cos inverse 0.8. Why I am taking minus? Because SL conjugate, we have to take SL conjugate. SA conjugate is equals to SL conjugate into ZB upon ZA plus ZB. So I am writing here, please observe. SL conjugate 600 at an angle of plus cos inverse 0.8, conjugate of that it will become minus cos inverse 0.8 into ZB upon ZA plus ZB. So what is the value of ZB here? 0. On the common base, ZB is 0.04 plus J 0.24. 0.04 plus J 0.24 upon ZA plus ZB. So 0.04 plus J 0.24 plus of ZA is 0.01 plus J 0.06. Now you can calculate this and find the value of SA conjugate. So this SA conjugate is the KVA shared by transformer A when it is operating with a transformer B having impedance ZB. Okay. So I am calculating this. Do the calculation along with me. So this will be 0.24 I plus of 0.1 plus 0.06 I. 0.04 plus of 0.024, 0.24 divided by answer multiplied by 600 at an angle of minus of cos inverse 0.8. So this will become, in my calculation I am getting it to be 480 at an angle of minus 36.8698. Please check whether I have done the calculation rightly or not. Those who are disliking this video need to put a जाने दो यार, क्यों बोला जाए, है ना, छोड़ो. हाँ, now see, Sir, we have this SA conjugate. So this is in kVA. Sir, if you know, if you have SA conjugate, you can calculate SA. SA will become 480 at an angle of 36.8698 kVA. It means in kilowatt it will become, 480 cos of 36.8698 384.0049 kilowatt at 0.8 power factor lag. Is it okay? So we have SA. If we have SA, we can calculate SB also. What is SB? Sir, the total load kVA is SL and the kVA shared by the two transformer. So kVA delivered by transformer A if known and load kVA is known, then we can calculate the kVA delivered by transformer B also. That will become SL minus SA. Is it okay? Yes, sir. So SB can be calculated in the simple fashion as SL minus SA. But keep in mind, this is a phasor sum. Don't do it directly, arithmetical. Okay. So you have to keep in mind that this is a phasor. 600 at an angle of plus of 36.86 minus. But when you are observing this, this is going to be same as 480 at an angle of 36.8698. Is it okay? Yes, sir. So their phasor sum and arithmetic, the phasor difference and arithmetic difference are same because they are in same phase. So sir, SB will become, that is why I am highlighting, you have to do the phasor sum. This is a special case in which we are getting both are in the same phase. So that is why arithmetical and phasor both are going to be the same. But you have to keep in mind that this is a phasor one. Okay. So sir, this will become 600 minus 480. So how much? 120 at an angle of 36.86. Is it okay? So kVA shared by transformer B we have, so kilowatt shared by transformer B also we have. This is kilowatt shared by transformer A. You can calculate kilowatt shared by transformer B. This will become 120 into cos of 36.86. Is it okay? Is it okay? Kilowatt at 0.8 power factor lag. One more thing we came to know, that both the transformers are operating at same power factor, same as the load power factor. So sir, is there any criteria to observe whether the two transformers are operating at same power factor and same as load power factor? Yes. What is the criteria? Please observe. If you observe here, what is the value of Z? What is the value of impedance angle? That is theta. If you try to find the impedance angle of both, that is tan inverse XA by RA and tan inverse XB by RB. So please observe 0.06 divided by 0.01, that is equals to 0.05, and 0.02 divided by 0.12, that is again 0.12 divided by 0.02, that is again 6, and 0.06 divided by 0.01, that is again 6. It means tan inverse 6 and tan inverse 6 both are same. Already we have discussed in conditions to be required for parallel operation. A desirable condition is that in case if X by R ratio of two transformers are equal, then two transformers will operate at same power factor and same as the load power factor. So I am hoping you are able to understand up to this part. Just by observing in the question, I know both are going to operate at same, that is 0.8 power factor. Is it okay? Most of the time we need not to write anything. Up to this part, I am hoping everything is clear. Now come to the next part. So if the two transformers having same X by R ratio, then both transformer will operate at same power factor and same as the load power factor under parallel operation. Is it okay? Now please observe, come to the next part. Up to this everything is okay. I am interested to know what is the maximum kVA that this combination can feed without getting overloaded any of the two transformers. Okay. Now please see. In order to find the maximum kVA handling capacity of parallel operation, please observe, important note, approximate maximum kVA that can be put on, that can be feed by parallel combination, that can be feed by parallel combination, feed by parallel combination. Are bolo, are you able to understand? You need to share this. Are bhai, you need to share this session. Please see. You need to share this session. Please see. Approximate maximum kVA that can be feed by the parallel combination without getting overloaded any one of them. What is kVA? SL, load kVA is equals to, please observe here. Please observe here. We have two transformers operating in parallel. So I am taking it from here. Please see. We have this to be the two transformers operating in parallel. Don't try to do it by in this way in your copy. You need to write it. Okay. Now you have to draw this figure again. Even I need to draw this. Please see. We have the two transformers to be operating in parallel. Please observe. Now please see. Let us assume that the impedance of transformer A and transformer B are ZA and ZB in actual ohms. ZA and ZB in actual ohms. Current delivered by transformer A, IA, and current delivered by transformer B, IB, for a load, say Z. Or you can just say for a load I. Load IL, that is equals to IA plus of IB. Okay. Now please observe here. You can assume it like EA and EB. If EA and EB are equal, you can assume it like a single source. And the single source is delivering current, and that current has two paths. One is having impedance ZA and one is having impedance ZB. We all know that current always try to flow through the low impedance path. So definitely maximum amount of current is going to take that path which will have lower impedance, and that side of the transformer is going to be overloaded first. Again sir, please see. If EA and EB are equal, and if we are going to increase the load, then current IA and IB increases. More current will be supplied by that transformer which will have lower impedance, because we all know that current always try to flow through the low impedance path. So that transformer feeds more current which have lower impedance. It means that transformer will get overloaded first. Please write down. Are you able to understand? Yes sir. So first of all we need to find ZA and ZB on their own per unit values. Sir, ZA, let us suppose, I am assuming here, please see. Please see. By observing the nameplate of the transformer, we know about ZA and ZB. If we calculate ZA, the magnitude of ZA is 0.01 plus J 0.06, and magnitude of ZB is 0.02 plus 0.02, 0.12. So you know how to calculate the magnitude, root over under root of real part ka square plus imaginary part ka square. Is it okay? already we can observe it here that ZB is going to be more than ZA. Yes. So sir, as per the given in the question, ZB looks more than ZA. So if ZB is greater than ZA, it means IB more portion of the current will be delivered by transformer A and transformer A will get overloaded first. Okay. Maximum load that this combination can feed is the rated KVA of 1 which is going to be overloaded first. So what is rated? Sir, voltage V into current delivered by transformer A is rated. However, at the same time, voltage V into current delivered by the transformer B, but that is not rated. Because the impedances are different. So definitely more current will flow by transformer A and transformer A will get rated first. Please observe here, the maximum KVA that this combination can feed is rated KVA of that transformer which get overloaded first plus operating KVA of other transformer. Now please observe, you can write here in this way, sir, V into IA rated, this will become SA rated. SA rated, it means rated KVA of transformer A plus of V into, can I write IB? IB is the operating current. Please observe here, since EA is equals to EB, not only in magnitude but also in phase, so you know that, sir, ZA, IA ZA is equals to IB ZB, where ZA and ZB are in actual ohms. Yes, sir. Okay, if IA ZA is equals to IB ZB, I can say here, at this particular time when the maximum load is delivering, then IA is IA rated. So IA rated into ZA is equals to IB into ZB. Please see. Yes, sir. So you can say, sir, from here, operating current IB when the transformer parallel combination feeds maximum load is IA rated into ZA upon ZB. Can I write in this way? Yes, sir. So I am replacing this IB by this equation. Please observe, this is IA rated into ZA upon ZB, where ZA and ZB are in actual ohms. Okay, sir, nothing is going to be changed. Up to this part, I am hoping everything is clear. Under maximum load condition, when the transformer is delivering maximum load, the voltage drop across this is the rated current into ZA. However, the voltage drop across this is the operating current into ZB. So I am writing operating current IB in terms of operating current IB in terms of rated current of the other transformer and impedance of other transformer. Okay, since we have to find the approximate, so I am just taking the magnitudes. Please observe, SA rated into, can I write in this way? Can I write in this way? Please observe. Please observe, can I write in this way? V into IB rated, I am going to multiply it by IB rated and divide it by IB rated. Nothing is going to be changed. Yes, sir. This will be your ZA and this will be your ZB. So mathematically nothing is going to be changed. Okay, sir. Now please observe, I am also going to divide it by V rated square to V rated square. Or you can just write it as V rated by V rated. Nothing is going to change. Yes, sir. Now please observe. Now please observe. Now please observe. V rated square. I am multiplying and divided by V rated square and V rated square. Nothing is going to change. Okay, sir. But now we can write SA rated plus of, please observe, we may write it as V into IB rated. V into IB rated can be represented as, I forget to write IA rated, na? This part is missed, IA rated. Okay. So I forget to write this IA rated. Please observe. V into IB rated can be represented as SB rated. Okay, sir. So SB rated into IA rated into ZA upon, please make it as V rated only, IB rated into ZB. Yes, sir. Okay, now please observe here. You can say, sir, this is the voltage drop, internal voltage drop in the transformer, and that I am going to represent in terms of percentage as V rated by V rated. Now please observe. If you observe this part, what is this? If you observe this part, what is this? ZA upon V rated by I. Sir, SA rated plus of SB rated. Please see beta, most of the students are not able to see this. That is why I am going so slow. Please observe. You can say, sir, this will become ZA upon V rated by IA rated. V rated by IA rated is ZA base. Yes, sir. And ZB upon, ZB is in actual ohms. ZB upon V rated by IB rated. V rated by IB rated is ZB base. So what is this? Actual impedance upon base impedance is per unit impedance. Wow, sir. So just by observing the nameplate, we are capable to identify maximum kVA that can be handled by the two transformer going to operate in parallel. SB rated into, this is your ZA per unit on ZA base upon ZB per unit on ZB base. If you remember, in the conditions for parallel operation already I have discussed that if the two transformers will have a same per unit impedance on their own base values, then they are going to share load proportional to their ratings. It means they are going to share maximum load. Is it okay? Are you able to understand up to this part? Great, sir. Are bolo yaar. Are you able to understand up to this part? You need to share the session as much as possible. So please, now you know about this formula. Sir, we have to take rated kVA of that transformer whose either actual ohms or per unit impedance is lower. And then the other transformer will operate at a value less than rated. And that can be calculated approximately as SB rated into ZA upon ZB. So that impedance which is lower will take an upward and the higher one is in the denominator part. Is it okay? You can use this formula to find the maximum kVA that parallel combination can feed during parallel operation. Are you able to understand? Hello Akshay. Are you able to understand? Arey bol do yaar. Bahut jabardast. Now please see. If you have to find the values, what is the values beta? Please observe. Already we have ZA and ZB on their own base values. On their own base values is mentioned onto the nameplate. So ZA is 0.01 plus J 0.06. ZB is 0.02 plus J 0.12. So put it in the formula to find the maximum kVA that this combination can deliver. Is it okay? Now please observe. I am writing here SL max is equals to, this single question holds three different concepts and all are important for all competitive exams. Now please observe. SL max will become SA rated. SA rated is 500 kVA plus SB rated is 250 kVA into ZA 0.01 plus J 0.06 upon 0.02 plus J 0.12. Is it okay? Only you have to put this to find the magnitude of maximum kVA that can be handled by this parallel combination. Is it okay, beta? So we are getting this to be 0.5 into 250, 125. So 500 plus 125. It means the maximum kVA that this combination can handle is equals to 625 kVA. By observing onto the rating plates, we think that they are going to share the load of 750 kVA, but no, they can maximum share a load of 625 kVA. If you are going to increase the load beyond this, then transformer A is going to be overloaded. Are we able to understand up to this part? हाँ बेटा, Z base is V base by I base ना. V rated by I rated is selected as a Z base because the nameplate per unit values are selected. Nameplate per unit values are calculated by taking rated values as a base value. Is it okay? Are you able to understand? यार मैं पैरेलल ऑपरेशन के इतने बड़े टॉपिक पे हूं, तुम अभी बट जॉइंट्स पे ही बैठे हुए हो यार. Are you able to understand up to this part? Great, sir. So now we know if the two transformers having same per unit impedance on their own base values, they are going to share the load maximum. Okay, if the two transformers having same X by R ratio, then both the transformers are going to operate at same power factor, same as the load power factor. I am hoping up to this part each and everything is clear. Now come to the unequal voltage ratio. All the formulas till we have studied are only for the equal voltage ratio case. Now come to the unequal voltage ratio case. Okay, so two transformers operating in parallel having unequal voltage ratio. Okay, so two transformers operating in parallel having unequal voltage ratio. Very rare chance to be asked in GATE, but a high chance to be asked in IES conventional. Okay, so rare chance. Why I am saying rare chance? Because there is a lot of calculation, but in GATE already one question will be asked from this, and that is circulating current. So they may ask about the circulating current in case of an unequal voltage ratio. Okay, so now come to the unequal voltage ratio. I am assuming that let two transformer, so I am making this EA to be greater than EB. Okay, so unequal voltage ratio, it means the induced EMF onto the secondary side of transformer A, I am assuming that it will be more than the induced EMF onto the secondary side of transformer B. Now please see, XA, RA, EA. Transformer can be represented by the voltage source along with the internal impedances. Okay, so if we represent the secondary side of the transformer, it looks like this. Okay, you need to share this session, beta, because I am not ready to drain my such a good content onto the YouTube and without getting love from the students. So it will be quite difficult for me. RB and XB. You need to share this session. EB. Let us suppose the load is SL. Load is SL at an angle plus minus phi L, where plus is for the lagging power factor and minus is for the leading power factor. This we have load, voltage V. Let current delivered by transformer A is IA and current delivered by transformer B is IB. Are you need to share this session on all Telegram. Wherever you are connected, you need to post the link of this session. Why I am saying this? Because it is in your hand how much content I am going to deliver on YouTube. It totally in your hand. Now please see, IA, IB and SL. Please see. Please see. By KVL, we can write EA phasor is equals to V phasor plus of IA ZA. Yes, sir. So if I am writing this V as, let us suppose the current taken by this is IL and the load impedance is ZL. So you can say, sir, this syllabus have instrument branch. Deepak Rawat asking, sir, no, parallel operation of transformers is not in the instrumentation, but up to the auto transformer only you need to read. Okay. Already I have completed in the impulse batch up to the auto transformer. So if you are going up to the auto transformer, that is sufficient. No need to study about the three-phase transformer. Only for the instrumentation. If you are from the electrical, must have to go by the three-phase transformer, because this year very high chance that the question will be asked either from the three-phase or from the parallel operation. From the last 2 years, they haven't asked any question from these two topics. So, and from, if you observe from the previous, then there are many times they have been asked a question from the parallel and three-phase. So very high probability that questions are going to be asked from this topic this year. Okay. Now please see, sir, EA can be represented as, V can be represented as V into IL. Sir, V can be represented as IL into ZL plus of IA ZA. Yes, sir. Further you can say, sir, this IL can be represented as, what is this IL? IL is the phasor sum of IA plus of IB, where IA is the current delivered by transformer A and IB is the current delivered by transformer B. ZA is the impedance of transformer A and ZB is the impedance of transformer B. Yes, sir. So, IL can be replaced by the phasor sum of IA plus IB. So, I am writing here as IA plus of IB into ZL plus of IA ZL. I am hoping up to this part each and everything is clear. Now please see, sir, from here you can say EA can be represented as ZL plus of ZA into IA plus of IB ZL. Yes, let it be equation number 1. Similarly, you can write for EB also. So what is the value of EB? If you observe, EB is equals to V plus of IB ZB, where V can be represented as IL ZL, where IL can be replaced by IA plus of IB. So we can arrange EB as ZL into IA plus of ZL plus ZB into IB. Is it okay? Yes, sir. Now this is your equation number 2. We know about EA and EB. What is EA and EB? No load induced DMF of transformer. We know about EA and EB right from the nameplate rating. We know about ZA and ZB from the nameplate rating of transformer. ZA and ZB. We know about load impedance ZL because we are going to connect the load. So we know about ZL also. The thing which is not known to us is current delivered by transformer A and B while operating in parallel. So the unknown parameter in this is IA and IB. So 2 equation and 2 unknown. So we can solve it. It is not quite easy because this is a phasor one. So don't go directly by solving it simultaneous. You have to go by the substitution method. What is substitution method? First of all, you have to find the entire equation in terms of EB, IA and ZB, ZL. Keep IB on one side and all other things on the other side. And then the value of IB can be put it here. Now the entire expression is in terms of IA and you can now find IA. Once you have IA, then you can put it in this and find the value of IB. Is it okay? Don't go by the substitution method because there are the phasor. All the values will have angle also. So best is to go by the substitution. Are you able to understand up to this part? सर मैंने आपका मशीन वीडियो से बहुत कुछ सीखा है. I got 510. गेट स्कोर 747. थैंक्स अ लॉट. शयान थैंक यू बेटा. एंड तुम्हें पता है सबसे अच्छा टीचर को कब लगता है? पेमेंट आती है उस दिन? नहीं यार, पेमेंट 10 साल पहले लगता था. 10 साल क्या 5 साल पहले लगता था कि जिस दिन पेमेंट आती है उस दिन अच्छा लगता है ना. अब जानते हो क्या अच्छा लगता है? Now I feel happy when my student write such a comment. It means I have done something, maybe 0.001%, but that is the very important for me. तो शांस तुम बेटा मेरे लिए बहुत खास हो. Thank you बेटा. Love you a lot. Maybe in the future you are going to get all the success, whatever you are dreaming for. Okay. Are you able to understand up to this part? So I am just writing here. Solving equation 1 and 2. तुम मुझे कांटेक्ट भी करना बेटा, ठीक है? 8882529229 पे. Solving 1 and 2. देखो जरा 1 और 2 को सॉल्व करने जा रहा हूं. तो 1 और 2 को सॉल्व करके क्या मिल जाएगा? IA and IB can be found, will be found ना. IA and IB will found. By solving equation 1 and 2 we found IA and IB. Once we have IA and IB, it means current delivered by transformer A and current delivered by transformer B. Now please see here. If we have current delivered by transformer A and current delivered by transformer B, then we can find KVA delivered by transformer A and KVA delivered by transformer B. Okay, now please see here. KVA shared by each transformer. KVA shared by each transformer is, KVA shared by transformer A is V into IA conjugate and KVA shared by transformer B is V into IB conjugate. So sir, it is quite easy. Yes. If we have more than 2 transformer, then under that condition we go by the Millman's theorem. We know how to use Millman's theorem. In Millman's theorem, if we have n number of sources having their internal impedances connected in parallel feeding a load, then by using Millman's theorem we can calculate the power delivered by each of the source individually. Is it okay? Current delivered by each of the source individually. So in case of 3 transformer or more than 3 transformers, we go by the Millman's theorem. For 2 transformer, you can go by this method also. Are you able to understand up to this part? Great sir. Now please see. Now please see. Now please see. Sir, up to this part each and everything is okay. But the difficulty is that most of the time load impedance is not given. Instead of giving load impedance, they will say load KVA and the power factor of the load. So how to find this ZL? So now please observe here how to find ZL. Before proceeding to the calculation, we need to find ZL. How to find ZL? Please see. If load KVA is given to you, then in the electrical equivalent network you can write ZL. Please see. Load KVA is V into IL conjugate. Yes sir. Where V can be represented as V can be represented as V into IL conjugate. What is the value of IL conjugate in the electrical network shown here? Sir, IL conjugate is, IL is V by ZL. So if you are replacing IL by V by ZL, so it will become V by ZL conjugate. V by ZL conjugate. Yes, sir. V into V conjugate is V square, because when we are going to multiply two different phasors, then angles are going to be added. So if this is V at an angle delta, then this will become V at an angle minus delta. By adding these two, V at an angle V square only, the magnitude only going to become upon ZL conjugate. So if you know about SL, you can calculate ZL from this, and then you can proceed for finding current delivered by each of the transformer when operating in parallel, KVA delivered by each of the transformer when operating in parallel. Are you able to understand up to this part, the two transformers operating in parallel having unequal voltage ratio? Is it okay? Are you able to understand up to this part? Adarsh Kumar, Abhay Tandon. Great. So sir, we know how to find the KVA, kilowatt, when two transformers operating in parallel having unequal voltage ratio. Is it okay? Is it okay? If you have any issue, please feel free to ask. So the content that I am feeling to be delivered on YouTube is possible. I am doing it. If you found anything to be discussed, if you want to discuss anything onto the YouTube, you can just ping me in the message. Definitely I will try to take that part also. Okay. If you have any issue, please write down in the comment section. Now one very important thing, most of the students found that some of the students follow the entire lecture, and definitely they will gain three important things, that is what happens if the X by R ratio of two transformers are same, what is the meaning of common base, and how to use the formula for parallel operation. Also they came to know about the maximum KVA handling capacity of two transformers operating in parallel. But only those students who have watched continuous. It is very difficult to watch continuous on YouTube, because most of you get distracted and you think that this is available on YouTube. So whenever I thought I am going to watch. So this lecture will become like a textbook. You have textbook. You can read the content from the textbook, but you never do so. Why? Because you think that the book is with me. I can read it anytime. There is a lack of self-discipline, and it is quite difficult. So if you are going to enroll yourself in some paid course, then that discipline will come into the picture. Always you are going to study for that particular time, which is going to be already framed for you throughout the month, throughout the year. So the continuity will maintain. And once you have a continuity, even you are a tortoise, then also you are going to beat the rabbit in this technical field. I am hoping you are able to understand. Sir, unequal voltage ratio of transformers are used for which application? Parallel operation, yaar. It is very difficult to get the equal voltage ratios transformer. If you are using the equal voltage ratio transformer, then they must be designed in the same factory, at the same time, in the same way, in the same nature of core. But if the two transformers are going to be designed in different era, like one is designed today and one in the future of after 5 years, then definitely there will be a slight difference in the material, in the windings. So automatically the turn ratio, or you can say either voltage ratios, are going to be slightly vary, and because of which there will be the circulating current exist within the transformer. Now we talk about the circulating current also. Please see, what is the circulating current? In case of unequal voltage ratio transformer in no load, in case of no load, unequal voltage ratio transformers operating in parallel. Please see what happened. In case if there will be a unequal voltage ratios of transformer under no load condition. No load means the switch is open. So this is your no load condition. Now please observe, this is your EA, this is your EB, and presently we are talking about no load condition. Then even in the no load condition, there will be a current exist in the secondary side of the transformer winding, and that current flows from higher potential to lower potential. We have assumed that EA is greater than EB, so you can say, sir, a current will start flowing from one transformer to another transformer. This current is called as a circulating current, and the magnitude of circulating current is EA minus EB, higher potential minus lower potential, upon ZA plus ZB. Always remember that they may be differ in magnitude, but they are always in same phase. So EA and EB may be differ in magnitude, but EA and EB are always in same phase. That you have to keep in your mind. कहाँ चला गया? I am hoping up to this part each and everything is clear. Okay. I will send PDF. All these content are already in the PDF format, in the explanatory format on Unacademy app. How to approach? Into the description box of this video, link is given. If you are going with that link, you are going to get all the previous lectures, special free class lectures taken by me. And then you can just follow each of the lectures along with the numericals. You can download the PDF from there. Okay, that will help you a lot. Please observe here. Most of the student thinks are how we have to structurize our study. For that you need to first download India's best learning app, that is Unacademy learning app, on your mobile phone. Then just open and do the requirements, whatever questions will be asked, choose GATE and ESC section, and then apply code VST101. This code is very important, VST101, because this is going to give you the access of all special free classes of all educators. Okay, there is a lot of difference, already I have told this. If you are going with plus, you are getting live class, doubt solving session. Every fourth class is a doubt solving session. You may go by the Iconic. In Iconic, you will get all the features of plus along with a personal coach, study booster sessions, and personalized test analysis. Fee structure for 12 months. This is a 12-month. It means all the videos which you found to be logged are going to be unlogged for the duration of 12 months. Not only that, you are going to get all the live lectures. Is it okay? That is the most important part. The fee structure is just 27,225, but you will not get this fees. You will get this fees only if you are using the code VST101. Be ensured that on the promo code VST101 code is applied, because this will gives you a 10% discount. Not only that, it makes me bounded to help you throughout your preparation, because it's my code, so you are going to be my student throughout, and you are going to get all the educators videos, but under my guidance. Under my guidance means I am going to guide you how to study on the platform. Okay, what is the structure you have to follow? Fee structure for Iconic is 66,600 for 24-month plan. You can use my code again to get 10% discount. So one code, multiple things. A special free class plus Iconic. Is it okay? If you found that, sir, some more discount is needed, so for that you can go by the combat. Not only you will get the discount, but also you are going to get challenging questions that enhances your knowledge. Okay, on every Sunday this test is going to happen, and if you are going to be a best performer in this test, then you will get free scholarship. It means throughout your subscription, your total subscription is going to be waived off. Okay, now please see, on 22nd Kasser officer is going to start power electronics. He is one of the best teacher in electrical engineering. So you are going to get a chance to learn power electronics from him, and also you are going to get a chance to learn analog from Ankit Goyal sir. Presently it is running. You are also going to get chance to learn synchronous machine from me in this batch, and BV Reddy sir is presently taking network. Okay, so register yourself by today. Do not miss this chance. Okay, there is a lockdown, so if you are following your study, then it will be very good, because presently the entire day you are doing nothing, just seeing some lectures on YouTube. Some of the peoples are gaining and some of the peoples are just wasting their time. So stop wasting the time, enroll yourself and start learning. Is it okay? This is the Telegram channel you need to follow for all upcoming videos. Also you can search electrical_machine by Varun sir on Telegram. Okay, our team, we are going to deliver our best on YouTube as well as a special free class for those students who are not capable to afford the fee. Is it okay? Please see, remember about this. Thank you everyone. Hoping you have enjoyed today's lecture a lot. Share as much as possible. Thank you everyone. Love you all. Love you all. Thank you everyone.